Hi guys, this is Daglish DL3MHT. I have a few projects lined up over the holidays, but as you can see, the desk is a mess, so let me clean up and then we can get started. I wish you and your families and your relatives happy holidays. Okay, and as you can see, cleaning up was a bit of an exaggeration. I just moved the crap to the other side behind the camera. So now we can have a look at my first toy that I got for Christmas. Okay, so as we are doing a bit of SMD soldering and tiny components assembly, I'm starting with a boring unboxing video. Got myself this Andonstar digital microscope, which will hopefully make the video quality a bit better of the videos. And I'm just doing the unboxing, and I discover it the same way you discover it. Okay, custom cut foam parts. Then we see a USB power supply, cable with some buttons on it. So that is HDMI cable, I think. Then we have another angled USB cable. This looks handy. It's not USB-C, but doesn't matter. And then we have the main unit. Okay, let's get that out. And anything else in the box? Remote control. Not sure why you need a remote control for an inspection microscope, but there you go. Okay, so box is empty. Put the foam stuff back in. Keep the manual, and let's have a look. So what do we get here? I mean, it's not the most interesting video, but I have high hopes that it will improve my SMD soldering. As I recently got new glasses, and they are so perfectly compensated for far sight that I have really problems with them near sight. So there's a chance that I need some office glasses or glasses for the workbench in a few years, but maybe this can help. So let me have a look. Okay, nice. It's all a bit wobbly, wibbly, wobbly. But I think, yeah, you can adjust the height. Mechanically it's not so bad, I think. Nicely done. LED lights. The rod is greased. Here we have the camera and the display on top. Well, I guess, should we look into the manual? That's the question. Does anybody look into the manual? Probably just to connect the power. Figure out the details later. Okay, so we need this thing and this thing. And then let's wire it up. Okay, the cat is making a racket downstairs. So what do we have for connectors here? SD card connector, USB and micro HDMI. So I guess the USB is also the power supply. I have no clue if I'm in frame here. So I probably have to reshoot this, because 50% of the video is out of frame. And here at the bottom you have the base for the LED lights. And then we just need the power. And of course I have to check how good or bad that USB power supply is. Probably creates noise all over the HF bands. Okay, plug it in, and okay, lights come on. Both lights are working. So what do we have here? We can increase the brightness and lower the brightness, which is nice. And I think this is just the button here for the light and the brightness for the light. So I guess it's just a Y cable. And yeah, the display here on the top is probably not in frame. Or is it? Almost not. Yeah. As I thought, my video is probably mostly out of frame. So can we see already something? Let's put something underneath. Yes. I have no idea. Do we see? I see something, but where do we adjust the sharpness of this thing? No, that's screwing it in. Don't know how far the distance is. I guess I have to pause the video quickly and figure it out, because that would take like 10 minutes. I see something blurry, but it's not focusing yet. One moment.
A few moments later.
And I'm back, and I think I figured out how this thing works. Well, basically like any other microscope, surprise, surprise. Basically, you put your object that you want to inspect. Here I have my old SMD soldering practice board under the microscope. And you can adjust the distance between the camera and the microscope. And of course, the further you go down, the bigger or more zoomed in the picture gets. So here I'm showing you the minimum zoom level basically. And then you twist here on this ring to put things into focus, and it's very nice depths of view, depths of field. Well, how should you say? Focus depths. So like here you can get the silk screen in focus, and you can also get the components in focus. And yeah, you can adjust your light here to make it look even more 3D. And you can adjust the brightness of the LEDs as well. So as you can see, this is the solder exercise, and you see all the fluff and dirt that has accumulated over last year. I was just lying around here in my shack. And I have a tape measure here, and I can show you the distance between the camera and the PCB. Let me get my arms around, and this is just a rough measurement. Don't nail me down, or don't take me down to the absolute millimeter. I think it's about 12.5 centimeter here from the camera to the top of the PCB. So with the maximum zoom level, and now let's zoom in. So basically go all the way down here with the camera and make sure we are still focused. So now I have to twist this bit in the right direction, and I'm twisting it in the wrong to get everything into focus again. And now we are getting there. You see every tiny speck of dirt. So for example, here we have a SMD LED. And as you can see, you can even see the, let me adjust the brightness a bit and get it into focus. So you can even see the bonding wire here on the screen. I don't know if it shows up on camera. So here with the maximum zoom level, you can really look at a single 0805 component and see if you soldered it properly or not. Let me see here on the side. I think we have 0402 components. Yeah, that's also, yeah, you see here the, while the 0603 still look acceptable and the 0805 are pretty good. And you go down here to 0402, you see it's too much solder and not properly centered, but hey, that was the exercise board. Okay, what else do you want to know? The minimum distance between camera and, well, the distance between the camera and the PCB at minimum zoom, maximum zoom level. Let me measure that as well. And we are about maybe 4.6, yeah, 4.5 centimeters, something like that. Okay, so mechanically it looks quite nice, I think. This is the, I haven't said which Andonstar microscope it is. Right, where did I put the box? I have to, oops. And now the camera is falling. No, the light is falling. I think it's the HD version. Let me have a look at the box. It's the ADSM302. And right, I've not tested the HDMI, mini HDMI output and the USB connection yet. But so far it makes quite a nice first impression and will surely help me with my electronics project. Okay, and what was the reason why I got this thing? Because while I was recording this video, something showed up. Look at this. Delivery from JLC PCB just in time for the holidays. And let me show you. I got the Christmas star, LED star that I was, let me try to get it to focus, maybe like this. So here you see, that was the PCB that I got from our friends in China. And this is basically to recreate an old project that I did as a teenager and gave to my dad. So this is like, I don't know, maybe something like 30 years ago, haha. And as I can't throw anything away, this is how it looked like. It's a little Christmas star with blinking, pseudo-randomly blinking lights. It has a small counter chip here, and the counter chip directly drives the LEDs. But as you can see, I was not very good to produce a proper PCB. Look how disgusting that looks. It was more like a rough guideline where to place the components, and the remains of the copper wire were a guideline how to manually put on lots of fixes and bond wires. So it was not my best work. And of course these days, you should not really do your own PCBs anymore. It's like you have to properly dispose of the photoresist when you develop your PCB, and you have to sorry, that was not the right way. The photoresist goes on the PCB and then you develop it. But then you have, of course, the remains of developing it and that you have to get rid of properly. And then when you etch it, you have the remains of the etching that you have to properly dispose of. So I think it's better when you let your PCB manufacture by some professional, and then you not only get a nicely etched PCBs, you get it nicely cut, nicely drilled, you get it with solder resist and with a silk screen, and the pads are already tinned and the wires are contacted through. And as you can see, this is basically, I got, I think, 10 of these. There was a discount currently available at JLC PCB because I'm not ordering so often. But it's basically cost me about 10-15 bucks, including shipping and custom handling. I mean, it's absolutely ridiculous. For that price, you can't do PCBs on your own. I mean, it's nice if you know how it works, but yeah, I mean, I think just one package of the chemical to etch the PCB costs like, I don't know, 20 bucks these days. Yeah, so there's absolutely no way that you can do it in that quality and for that price on your own. But yeah, times change. So, right, I got 10 of these nicely made PCBs in order to revisit this nicely blinking but very ugly looking teenager project. And yeah, maybe I'll make it a live stream and I stream the assembly. And that will be a nice training before I move on to the QMX Mini, which is also here. And which is a pretty, well, it's not, doesn't look impossible to do, but you need some time for yourself and be, you know, collected and have a calm hand and always know when to stop. When you're building one of these more complicated projects, it's always good to know when to stop. So don't build it in one go. You know, spend a few hours, 1 or 2 hours on it, and then take a break and come back the next day. And that's the best advice I can give you. But this one should be easy enough to maybe do in one go in a live stream. I don't know. Let's see how I have time the next few days. Okay, so that was the unboxing of the Andonstar USB inspection microscope and maybe a small look out what I will do with this. So thanks for watching, and once again, Merry Christmas.